but I definitely need to have the human experience to be a good and understanding friend.
Imagine a world where one robot can handle almost every task, from sweeping the floors and running errands at home to assembling cars in a factory, or even rescuing people in dangerous situations. Today's video explores the future of robotics and how cutting-edge machines like Tesla's Optimus and Boston Dynamics' Atlas are paving the way for this all-in-one solution. Let's start with the vision behind multi-purpose robots. For decades, scientists and engineers have dreamed of creating a machine that could seamlessly blend into our lives and take over tedious, dangerous, or repetitive tasks. Now, that dream is starting to materialize thanks to advances in artificial intelligence, machine learning, and mechanical design. With improved sensors and autonomous control, modern robots can not only mimic human movements, but also learn new tasks on the fly. One of the most talked about projects is Tesla's humanoid robot, commonly known as Optimus, or Tesla Bot. Announced at Tesla's AI Day and refined over the last few years, Optimus is designed to be a friendly, all-purpose helper. According to Tesla, this robot will be capable of performing everything from grocery shopping and mowing lawns to helping out in factories, and even serving as a companion at home. Elon Musk has boldly claimed that these machines could revolutionize the way we work and live, potentially leading to a future of abundance where labor-intensive tasks are automated and human creativity is freed up for more meaningful pursuits. The design of Optimus is strikingly human-like yet minimalistic. Standing about 1.73 meters tall and weighing just 57 kilograms, it features 2 arms, 2 legs, and even an interactive screen that serves as its face. While early prototypes required human control or assistance to perform tasks, the latest demonstrations show improvements such as better balance, refined hand movements, and even the ability to sort colored blocks or perform yoga stretches. Although some critics argue that many of the robot's tasks are still teleoperated, Tesla insists that the long-term goal is full autonomy. Musk envisions a future where Optimus will be available for under $30,000, making it accessible for both industrial use and potentially even home use in the years to come. In parallel with Tesla's ambitions, Boston Dynamics is taking a slightly different approach with its humanoid robot, Atlas. Originally introduced over a decade ago as a hydraulic machine meant for search and rescue, Atlas has undergone remarkable evolution. The early versions were known for their awkward, almost childlike movements and frequent falls. However, over time, Boston Dynamics replaced cumbersome hydraulics with a fully electric system that has made Atlas more agile, precise, and energy efficient. The new electric Atlas is built to work independently in challenging environments. Recent videos show Atlas performing complex tasks, such as moving engine covers in a factory setting, all without any human intervention. Using advanced machine learning and a suite of sensors, including RGB cameras, LiDAR, and depth sensors, Atlas can detect objects in its environment, plan its movements in real time, and adjust its actions when faced with obstacles. For instance, when an engine cover isn't positioned correctly, Atlas reevaluates its approach and successfully relocates the object without any external help. What sets Atlas apart is its focus on autonomy and real-world applications. Whereas some robots are designed primarily for research or demonstration purposes, Atlas is intended to tackle practical, often dangerous tasks in environments where human presence might be risky, such as disaster zones or hazardous industrial settings. Its ability to adapt to uneven terrain and work continuously in challenging conditions illustrates just how far robotics has come from those early days when robots could barely walk without falling. Both Tesla's Optimus and Boston Dynamics' Atlas showcase the importance of integrating artificial intelligence into robotic systems. Reinforcement learning, a process where robots learn from trial and error, has accelerated the development of these machines. By simulating real-world scenarios in virtual environments, engineers can teach robots complex behaviors more efficiently. This technique has been instrumental in enabling Atlas to learn to manipulate objects and navigate dynamic settings with minimal human guidance. The promise of these advancements is enormous. In manufacturing, robots like Optimus could handle the assembly of vehicles or electronic devices, significantly reducing human exposure to repetitive or dangerous work. In logistics, Atlas might sort and transport items autonomously, ensuring that warehouses run smoothly and efficiently. And in homes, a future where a friendly robot not only cleans and cooks, but also serves as a companion or caregiver isn't as far-fetched as it once seemed. However, it's important to acknowledge the challenges that remain. Despite the progress, there are still technical hurdles, such as ensuring battery longevity, perfecting the robot's ability to handle unpredictable environments, and making them cost-effective for mass production. Moreover, while AI has advanced rapidly, translating those advances into physical, reliable movements in the real world is a complex engineering problem that requires constant iteration and testing. There are also social and ethical questions to consider. As robots become more capable, concerns about job displacement, privacy, and safety are on the rise. Will widespread adoption of these machines lead to an era of unemployment for low-skill workers? Or will it free up human labor for more creative and rewarding tasks? How do we ensure that these robots are safe to operate in homes and public spaces? Addressing these questions will be crucial as we move forward into this brave new world of robotics. What's particularly exciting is that the race isn't just between a few companies. There are multiple startups and research groups around the world, each experimenting with different designs and control systems to create robots that can perform a broad range of tasks. For example, aside from Optimus and Atlas, companies like Agility Robotics and Figure are also developing humanoid robots with specialized capabilities for tasks like box moving and household chores. This diversity in approaches means that even if one type of robot encounters setbacks, others might fill in the gap, driving the entire industry forward. One recurring theme is the emphasis on making robots that are not only highly capable, but also safe and friendly in appearance. Tesla, for example, has worked hard to ensure that Optimus has a non-threatening design with a friendly interface. The idea is that if robots are to work alongside humans in factories, in homes, or even in public spaces, they must be perceived as approachable and non-intimidating. In contrast, Atlas, while incredibly agile and powerful, is more utilitarian in design, reflecting its focus on challenging industrial tasks rather than everyday household functions. Ultimately, the future of robotics is about more than just technology. It's about transforming how we live and work. Imagine a future where factory workers collaborate with agile robots that can handle heavy lifting, where warehouse operations run 24/7 with minimal human oversight, and where households have their very own personal assistants to help with daily chores. Such a transformation could lead to increased productivity, safer work environments, and more leisure time for people to focus on creative and strategic endeavors. At the same time, these advancements invite us to rethink our relationship with machines. As robots become more autonomous and capable of learning new tasks independently, they may start to exhibit behaviors that seem almost human. Whether it's through playful interactions like dancing and serving drinks, or through practical demonstrations of object manipulation and navigation, these robots are blurring the lines between science fiction and reality. To wrap up, while challenges remain in perfecting the technology and integrating it into society, the rapid pace of innovation in robotics gives us reason to be optimistic. Tesla's Optimus and Boston Dynamics' Atlas are just the beginning, a glimpse into a future where robots can do it all, serving as assistants, workers, and even companions. The journey is far from over, but each breakthrough brings us closer to a world where the line between human and machine becomes ever more seamless. Stay tuned as we continue to explore these fascinating developments, diving deeper into the technology that's set to redefine our daily lives. With continuous improvements in AI, sensor technology, and materials engineering, the robots of tomorrow may truly be the ones that can do it all.